So here we're looking at the last lesson in our unit on functions. And this warm-up that we're looking at here, it's actually just kind of a puzzle brain teasery type warm-up, so I'm actually not going to focus on it, and I'm not even going to tell you the answer. But feel free, if you want to go ahead, give it a try, and then when you come into school you can show it to me and I can let you know if you have it right or not. But really it is just kind of a brain teaser, putting the numbers 1 through 8 in the boxes. And it says that no two consecutive numbers can be next to each other horizontally, vertically, or diagonally. So that means the 1 can't be next to the 2. Consecutive means right next to. When you're looking at the number 5, 5 can't be near 4 or 6, the two numbers on either side of it. So go ahead, give it a try when you have a chance. Today we're looking at qualitative graphs. I think you'll really like this lesson because we're going to be in math class and not use any numbers at all today. We're going to be looking at the graphs, but these graphs don't even contain numbers. Okay? So just kind of follow along, see what you can get out of it, and we'll go from there. So a qualitative graph. The definition is a graph used to represent situations that may not have numerical values or graphs in which numerical values are not included. So basically, again, no numbers. Right? What's very important, though, with qualitative graphs, because you don't have numbers, are the labels. Okay? Without the labels, we don't even really know what we're talking about. So here we're looking at time, and we're looking at percent downloaded. Okay, so we're downloading something, and we're looking at the percent that it's downloaded over the course of certain time. So as we start out and we see the time going on, you can see that it was actually downloading pretty quickly. Like we had a pretty big jump here in this time limit. Then we can see that the download actually kind of stopped. It steadied out. It kind of flatlined, so to speak. Then it started downloading really quick again, then kind of slowed down, and then started downloading fast again over the course of this time. So that's all we're really looking at with qualitative graphs, is being able to look at the graph and kind of describe it as I just did. What's happening over the course of the time or over the course of the x-axis label. So here's the first graph we're going to look at. The graph at the right displays the water level in a bathtub. And we want to describe how the water level changes over time. And you're actually going to see me not write a whole lot in this lesson, because we're just going to be describing it. So look here, we're starting at time 0, okay, so 0 seconds, and all of a sudden the water level gets really, really high, and then it levels out, and then the water level goes down. So think about filling up a bathtub or filling up a bucket of water or a sink that you then have a drain in, something like that. And what do you think's happening? I hope what you think is happening is that here the water level filled up. Then at this point right here, we've turned off the water, and the level remains the same. And now we're done giving the puppy a bath. So now we're going to open the drain and let all the water drain back out, and the water level goes back down. So basically that's what you would put it as a description. The tub is filling up. The tub levels out, the tub is draining. And you would get full credit for the problem. Here in this next problem, okay, we're looking at the rate at which Hector hiked along a path. Okay, rate is his speed. So we're looking at his speed as he's hiking. Okay. So you can see that he starts off and he's hiking at a pretty good speed. This does not mean that Hector is climbing a hill. It just means that Hector's moving relatively fast. Maybe he's jogging. Okay. Then this flatline piece right here. You notice how his speed stays the same. So he's going at a constant speed there. So he's walking at a constant pace. He's not stopped. He's just walking at a constant pace. Then he slows down a little bit. Then all of a sudden, very quickly, his rate picks up. He might have been running there along that point. And then here at the top, you'll notice this big drop-off. All right, Hector did not fall off a cliff. What this big drop-off means is actually that Hector stopped at this point. Okay, he stopped. His rate stopped. Okay, prior to this, he was constantly moving, but at that last point, he actually stopped. Another one, here we're looking at temperature over the course of a day. You'll notice that this one isn't quite as sharp and jagged as the other ones, because temperature is going to be more on a gradual rise, probably till about noontime. That's usually your highest temperature during the day. Then it'll start to cool back off over the evening. So you're going to try these two on your own. The first one is talking about the sales at a clothing store over the course of time. And then we have the distance Lewis is from home as he walks his dog. So try them on your own, pause the video, and then we'll come back and talk about them. So here with this one, we're looking at sales. Whoop, I don't want to move the paper. Sales over the course of time. So here you can see that the sales increased, then they decreased and steadied out a little bit. Then they had a really big increase again over a short amount of time. Maybe that was coming up into the Christmas season as we are. Black Friday and the holiday season where their sales really picked up. Then they slowed down for a little bit and kind of steadied out again, and then finally picked up there at the end. Second graph with Lewis and his dog. This time we are the distance from home. So here's home, this bottom point right here. So Lewis is walking away from home. Now he stays at the same distance away from home. So maybe he turned left or right. He wasn't walking any further from his house. He might have just been walking in a different left or right direction. Then he goes further from his house again, and then he walks home. This time we're going to create our own graph. So here, reading the situation, a tennis ball is dropped onto the floor. Think about when a tennis ball drops on a floor. It hits and bounces and goes up again and bounces and goes up again and bounces and goes up again and so on and so forth. And that's what we want to do. We want to create a graph to represent this situation. So my x-axis is going to be time and my y-axis is going to be distance. Because I want to know what that ball is doing. In this case, at time 0, the ball is going to be way up here, okay, because we're dropping it. So at its starting point, it's actually above the floor. That ball is quickly going to come down to the floor, bounce back up, come down, bounce back up a little bit higher, down, bounce, down, bounce, down, bounce, until it comes to a stop. Now, it may look like this is over a long amount of time, but we actually don't have a lot of information about the time. Maybe this time is only representing 0 to 1 second. Okay? And that's something that we don't actually know. So we just kind of have to figure it out to the best of our ability. So here we're looking at a graph with the child's distance from the ground as they swing. So again, time on my x-axis, we have distance on the y-axis. I'm going to abbreviate it this time. So we're looking at the distance from the ground. Well, when you start swinging, you're at your distance from the ground, and then you kind of go further away from the ground, and then you come back down closer to the ground, and then you go further away from the ground, and then you come back closer. So it's going to look something like that. Basically, you're just going to want to kind of picture what happens when you're swinging back and forth. Okay, you go away from the ground, then you come back down. And then you go backwards, and then you come back down. Then you go forwards, and then you come back down. And so on and so forth. Try this one on your own. Car is traveling at a constant speed. The car slows down steadily to stop at a stoplight. So go ahead, try it on your own. I'm going to pick a pretty different color. And I'm going to go from there. So looking at it with me, the car is actually traveling at a constant speed and then it slows down to a stop. So here's my time, here's my speed. So this bottom point down here is representing when the car would be stopped. And since it was traveling at a constant speed, that's how we get that steady line at the top and then the drop off down. Your homework tonight is actually in your book. If you don't have your book with you, you can always use the textbook website, which is www.connected.mcgrawhill.com. And you can use the online book to come up with those problems. Some of them will be graphs where you just have to interpret, and some of them will be ones where it will actually ask you to create the qualitative graph.